Yeah, hey everyone, this is Dwayne with Good Works Auto and Dwayne's Diagnostics. And I don't know if you can see me very well, but I just figured I'd put myself on the camera because I never show myself. So I figured I'd just show my face on this one. And I don't know how to, I'm not good at photography or nothing. I don't know about lighting or anything. So I can't see myself really good on here, so I don't know if you can. But I figured I'd just put my face on the camera. But I'm gonna turn the camera around now, show you what I got going on. But basically I thought this trailer light problem would be actually a good way to teach different ways of testing this type of problem. And for anyone who saw my other videos, you probably already know that there's a short in this wire right here, which I can show you with the test light. I've got the test light hooked up to battery negative right here, and this is the wire that was having the problem. And you can see I got a test light there. I got power on that wire. Right here is where that wire rubbed or got pinched and rubbed. And I got power right there. But if I just move over like a 1/4 inch or so, I have no power right there. But I have power here. Just not right here. So this wire is broken or corroded and has an open right here. But I figured what I'd do first is show you how a good wire test or how a good light test. And I have power hooked up here from the jump box to both of the back tail lights. On this green wire, that's actually the bad wire, and on this green and brown and yellow and brown wire. And I can show you back here. That light's on. And this is the wire right here. This yellow and brown wire is the one getting power right now. So about 11.8 volts at that light, which should be about what we have on the battery also. 11.84. So the wire from this connector all the way back there is good and getting full power. Then I'll show you on the other side. That one's lighting up on this green and brown wire. And I've got it jumpered with this little jumper lead going up to the wire that connects to the light. It should be, the voltage should be about the same. Yeah, 11.8. And I showed you we have no power on that on this green wire. This is the broken one that has the open. And we're not getting no voltage there on the power probe. You can see the meter's hooked up to the good wire, and it's showing about 11.54 volts. If we hook it up to this other one, the bad wire, 0.012. So we have no voltage on this wire, which we already knew. But that's one way you can check the wire with a voltmeter. You know, you don't have to have a power probe. But like I showed you, you could test it with a test light, and you can test it with a voltmeter. So you know, you would know if it shows up as 0, you don't have voltage here. So you'd have to trace the wire back to wherever you can find battery voltage. So also another way, if you have one of these type of clamps, an amp clamp, you can actually just check and see that the wire has amps going through it. That's showing about 110 milliamps. So that wire has current going through it, or one of those wires do. This green and brown one. Right there it's lower because I have a resistor rigged in to that wire. But now I can show you when I apply power and bypass that open. I've got this piercing probe hooked up, which is basically bypassing this open right here. This piercing probe is coming. I didn't have it hooked up there, but now it's hooked up to battery positive, running all the way up to this green wire. And I guess I can't show it the way I got it hooked up, but now there should be power on this green wire being fed through that piercing probe. And the light looks a lot brighter now, because I guess all of the LEDs are lighting up. And now we have 11.26 on the meter that's hooked up to that bad wire. If I test it with the power probe, 11.51. So I'm just going to unhook that one so I'm not draining juice out of my jump box. I'll show you another problem here. If I got all my wires set up right here, see, we're going to power here. Okay, yeah, I think I got everything set up right here. So we should have the same voltage as we originally had on this power probe. 11.79, and put the meter back on it. 11.53. And what I got going on here is I have a 20 ohm resistor wired into that power feed wire on the green and brown wire. I'll show you, this is one of the type of problems you might encounter in troubleshooting electrical problems. But the power's coming in right here on this green and brown wire through these alligator clips, going through this 20 ohm resistor to this other alligator clip, and then it'll come through this alligator clip up on the green wire back up to the light. So if I clip it on down here at the end of that resistor, see our voltage drop to 10 volts. So about 1.5 volts drop right there according to the meter. And same thing on the power probe, about 1.5 volts or 1.6 volts. So this resistor, I put it in there basically to like simulate if you had a wiring problem. Like this resistor could be like if you had corrosion in the wire, or corrosion at a connector, or broken strands of wire on the power side, you would have more resistance in this wire on this circuit, which would drop your voltage like you saw there. You know, now we only have 10 volts available going to the light. So the light, it might not show up on here, but the light would be dimmer, it wouldn't be as bright, depending on the amount of resistance you had in the circuit. Like, you know, I could rig a 100 ohm resistor instead of a 20 ohm resistor, and then that light would be a little bit dimmer due to higher resistance. And I'll show you another thing here. So I'm hooking the green wire back up to the green and brown, and well, I was going to show you the amount of amps flowing through there, but looks like the battery on my meter is dying. But if it was working, you would see the way I got it rigged up here, you know, straight to the power wire, we would have more milliamps going through there to the light than if I had it rigged up back up to this resistor here. With that resistance, it would reduce the amount of current available to that light. So anyway, I don't know if that might be helpful to anyone or not, but I just figured I'd show that's a couple different ways you can test a circuit and test for available voltage. And if you got 0 volts, you know, you got an open or something not being turned on supplying power, or a bad ground. Which I don't know, I might be able to show you a ground problem on this video too. I'll see what I can do here, what I can rig up. Yeah, so I decided not to try to create a ground problem to show you anything like that on this video. Maybe I'll do another video on that. Well, I will eventually sometime, but yeah, I'd have to like disconnect these lights and rig in some resistors and stuff, and I don't really feel like doing that right now. So I'll show I'll show something like that on another video, what a ground problem looks like. But yeah, I hope someone out there liked this video and maybe learned something from it, or was maybe entertaining in some kind of way. But yep, that's it on this video.